Okay. So we have to remember that we're doing components. So if I drew a triangle so I didn't have to, so mostly because you didn't have to. If we get a force and it's not at 90 degrees, right? It's not straight across and it's not straight up and down, that's a problem. Because we like force net equations straight horizontal or straight up and down. So if we get a weird force at an angle, we want to break it into two pieces. We want to break it into its up and down component and its left and right component. And to do things, we need an angle. I like to keep all of my angles to the horizontal because that way we can say Fx is equal to the main force multiplied by which trigonometric ratio. I just like that word. It's a great word. It means sine, cos, tan. Which one of them is x? Cosine is always x. So, if I want to find this lower side of the triangle, it's the cosine of the angle. And if I want to find the up way, we use sine. Now, this is always true if the angle's here. If the angle goes up here, then these switch. So, if you have an angle up high, then you have... Oh, at least move my copy. Then you would best... the best way to do that is move the angle, because you guys know how to switch angles, right? And if your angle up here was, say, 30 degrees, what's the bottom one? 60, and how did you do it? You subtracted from 90, right? Because they all have to add up to 180, and one of them's already 90, so the other two have to add up to 90. So that's probably the easiest way to do it. Switching these in your head is probably a recipe for a mistake. It's easier to change the angles to off of flat than to do anything else. All right, let's see how good you are at components. So, exampling. So my first example is just a reminder of how we do components and adding up all the vectors. So, basically I got 3 people pulling on a tree with ropes. 15 newtons at 65 degrees. The 16 newtons at 135 degrees and 11 at 195 degrees. Where is this tree going to fall? It's a whole bunch of weirdness, but what we're going to do is we're going to start. Let's put a tree in the middle of a picture. Now what we're going to do is we're going to draw it looking straight down because that's the best way to do this. So here's our tree in the middle, and I'm going to set right here as 0 degrees. You can put it anywhere you want, but I think to the right is the right call, just because it's going to be the same as what you do in Math 11 and 12. So if you're not already in Math 11, and you have that later in the year, and when you do Math 12, this is where 0 is in math, so it's might as well. You can pick anywhere around the whole circle, and it won't change your math. So we should draw our 3 forces. The first force is at 65 degrees, so somewhere in that direction. That'll be F1. Now, where would F2 be? 135 degrees. Like right about there. All right, that'll be F2, somewhere over there. And where would F3 be? Be down a bit, right? Because all the way flat would be 180, and this is 195. So it's just a little bit past flat down. So somewhere, maybe there. That'll be F3. Now, we want to guess, if you had a guess, where is the resultant force going to go? Like, somewhere in this direction, right? Yeah. So somewhere pretty close to force 2, but that's what we hope. So when we get our answer, that's what our guess is going to be. So hopefully our answer is somewhere near 130 probably. These kinds of guesses are good. It helps us draw good diagrams and helps us be confident when we do all this math. So I already told you how to do most of these vectors, so this shouldn't be brand new. What do we have to do for each of our vectors? We have to get, for each 1, 2, and 3, we have to get x and y for each. So first, we're going to get all the x's together. I think this is the easiest way to do. To all the x's, then do all the y's, and then put them together. So we need to find the, let's change this to this color, f1x, and then f2x, and then f3x. Right, we're going to break these apart into these 3 components. So we take the main force and multiply by cosine, because that's our x component one. So we get main force for F1 is 15 newtons, and we get a cosine of 65 degrees. Main force for force 2 is 16 times the cosine of 135 degrees. And then we get, let's put brackets in it, and brackets of 11, and the cosine of 195 degrees. Wonderful. So getting all these cosines put into your calculator. What do we get for cosine of 65 times 15? 6.3 is great. That sounds good. 6.3. I think I'm going to put 3 in it to keep my digits up. We'll put 2 decimal places after these ones. What about 135? Yeah, negative 11. Does that make sense? Yeah. Why negative? Because going left, right? It's this little piece right here. It's going like, it's back from where we started. So negative is a good thing. It's good that it's negative. 11.31 newtons. Well, last one. A negative, you said? Yeah, negative 10.6, right. Because that's again 2, right? It's, I think it's 6.3 to the decimals that I wanted. Yeah, that's good because it's also left. All right. What's fx all together? Is all of them f1x plus f2x plus f3x. So really it's a subtraction. Right? So we're going to have the first one minus the second minus the third. Just add all these numbers, including their negative signs. And what do we get? Do we get a negative number?
Negative 15.
Negative 15 seems good. There, does that agree with our initial prediction? Of like, kind of to the F2, kind of over this way? That's good. It's a little bit left, which is good. Now we're going to do exactly the same thing with y. I'm going to slide this up. We're going to do exactly the same thing with y. Just going to put it over this corner. F1y, F2y, and F3y. And it's exactly the same, except we use the sine angle. 16 sine of 135, and then 11 sine of 195. These are all degrees. And multiply here. Okay. All right, try those and see if they agree with your predictions. Because again, unfortunately, a lot of the problems with these component problems or calculator problems is if you can get these numbers the same as I get these numbers, then that's a good starting point. Let's add all those up. Fy is going to be all of the other ones added up. F1y plus F2y plus F3y. So we add up all of these things together now. So this plus this plus this is going to be a negative. So do you expect overall positive or overall negative? before you even typed it in your calculator. I know some of you have already done it because you saw the pattern. I get 22, I think. Is that the right number of decimals?
Yes.
Okay, good. Okay, now what?
10.
Right. Now we have a new vector because we have a new x and a new y. So let's draw my new vector. So I'm going to draw a little triangle over here in my next corner here. It goes up 22. It's there. Goes up 22. Right? And it goes to the left 15.61, and this is 22.05. So my resulting vector is somewhere in there, right? This is my total force. Yeah, it's going to be the hypotenuse, but this feels right where we want our guess, right? Our guess was somewhere over here, so it looking like this is a good thing. If you put these backwards, like if you didn't get the negative here, you'd go pointing it this way, which would be wrong. Which is why drawing diagrams and having predictions is worthwhile, because it's really easy to get this negative switch and point the wrong direction. All right, so now we can try to figure out this. Pythagoras is an excellent tool here. So your force is equal to the square root of the x squared plus the y squared. All right, we're experts at this because I forced you to do it at the beginning of the year, which I think is good for you because sometimes this is the first time they're doing it. All right, what do we think for the total force size? Anyone has this finished yet?
27.
27 is excellent. I think it's 27. Does everyone like the number 27? 27. I should put at least one decimal with it. Is there any other numbers? It's 0? Okay, 0. Okay, sure. We'll leave it at 10 here so far. And this feels good. Like if I got 15 here and 22, 27 feels like the right number. Right? Don't forget to square root because that would give you a number in the thousands, and that's far too big. It'd be like 5,000 something. All right. I have to figure out this angle right here. How do I do that? Yes, SOHCAHTOA, but I'm going to use tangent. The angle is the negative tan of the Fy over Fx, which I think I put on your formula sheet. Kind of. I did. So what's the y number? Y is 22.05, and this one was 15.61. So I get an angle, a little bit down the bottom here, so slide up a bit. What angle do you think it is? $54.7. I like that. I think I like 54.7. Good, right? Everyone else gets 54. Guess you're all totally trying this. Now, is 54 the final answer?
No.
Not really, because if we look at our triangle, 54 is only what's in here. We need what angle comes all the way around.
So 180
Right. So remember, I kind of need the angle from here to there. So to get that final angle, we'll call that red theta. So red theta is going to be 180 degrees minus 54.7 degrees. That should be 125.3. Which is excellent news. Why is it excellent news? It does make sense. It's right beside where we guessed it, right? F2 is 135, so a little bit beside it. It's pretty close to F2 without being the same. It's just a little bit inside. So it would be, let's see where I can put it. Somewhere like here. I guess that would be my total F. Somewhere in there. So, as writing my final answer, it would be final F is equal to 27.0 newtons at 125 degrees. Yeah, that's probably enough. Excellent. And that's the end. We're finally done.
What about sig figs?
Okay, what sig figs should I keep? How many should I do? Let's take a look. Gosh, it looks like I have to keep just 2, don't I? All right, so let's change that final answer. Got to get rid of that. Well, stop being so right. I was so ready to be done this question. And you happen to be right. 27 newtons at 125 degrees. So we have to get rid of that 0.0. It's just 27 because I only have 2 significant digits. We usually don't care about angles. It's usually a thing. Angles we don't usually worry about. Because actually the angles is fine at 125 because we're doing a subtraction. So a subtraction just keeps the number of decimal places and not the number of significant digits. So that's fine. So 27 and not 27.0 is a better answer. Any questions about this stuff? This is our components, which we have to get used to. Yes, question? How are you? Wonderful.